Let me ask you a question. You have set up a powerful AI system with multiple GPUs, high end CPUs, everything looks perfect, but your training model is still slow. Why? Because your storage cannot feed data fast enough. And this is one of the biggest mistakes engineers make. They focus on compute but ignore the storage. So, in today's video, I'm going to walk you through the 5 key types of storage for AI. Now, what they are, why they exist, and how to choose the right one for your architecture. Let's understand the real problem. Imagine you are training a machine learning model. Your workflow will look like this. You will have loading data set, you will have the pre-processed data, you will feed it to the GPU, and then you will train your model. Now, here's what happens in reality. Your data set is sitting in storage, your GPU is waiting for data, storage is very slow, and then your GPU becomes idle. Now, this is what is called as IO bottleneck. And here's the scary part. If your GPU costs $3 to $10 and it's idle for 30% of the time, you are literally burning money. So, solving storage is just not optimization, it's cost saving. Before jumping into types, think of AI storage as layers. Cold storage, that is cheap and deep, where raw data lives. Warm storage, capacity optimized, where training data is accessed. And then you have the hot storage. This is high performance, where data is processed in real time. Now, the closer storage is to the compute, the faster it is because of low latency, but it's again more expensive. So, designing an AI system is about balancing of cost, performance, and scalability. First up, object storage. Think AWS S3, Google Cloud Storage, Azure Data Lake Storage. This is where your raw training data lives. Images, PDFs, audio files, CSV dumps, JSON records, basically all of it. Now, why do you use object storage? Because it's massively scalable. We are talking petabytes without breaking a sweat. Now, it's cheap. You're paying cents per gigabyte per month. Now, it's durable. Providers replicate your data across multiple availability zones. In an AI workflow, object storage is the starting point. Your data engineers dump raw data here, your data scientists pull from here to run pre processing jobs, your training jobs read batches of data from here during the training loop. Now, object storage isn't fast in the traditional database sense. You're not querying rows, you are fetching files. But that's okay. AI training pipelines are built to handle this with things like data loaders and streaming injection. Data loaders and streaming injection are software utilities that efficiently feed data from a dataset into a model. It's crucial for high speed training. They transform your raw data by batching, shuffling, and pre processing it, often using parallel worker process to prevent GPU to CPU bottlenecking, allowing models to train faster and more efficiently. So object storage key names you will see are AWS S3, Google Cloud Storage, Azure Blob Storage, Mini IO for on-prem. Now, when do you use it? Like anytime you're storing raw data sets, model checkpoints during training, or large artifacts like audio files and videos, when you don't use this storage. So, object storage is not designed for low latencies and high frequency reads. If you're directly training model from an object storage at scale, your performance will significantly drop.
Okay, this one is probably the most exciting of AI, vector databases. Here's the problem they solve. Traditional databases are great at exact matches. You say, find me the user ID 42, done. But AI doesn't think in exact matches, it thinks in meaning. When you use a large language model, your text gets converted into a vector, long list of numbers that capture the semantic meaning of the text. For example, the cat sat on the mat and a fur line rested on the rug would have the vectors that are very close to each other in high dimensional space. Vector databases are built to do one thing insanely well: find the nearest vectors to give query vector at scale in milliseconds. This is what powers your RAG, that's your retrieval augmented generation, where your AI lookup relevant documents before answering. Semantic search. Show me articles similar to this one. Recommendation engines. Similar to this, users also liked. Now here are the key names which comes into picture. One is your Pinecone, Waviate, Odorant, Milvius, and even Postgres with the PG vector extensions. Here's something cool. Cloud providers are baking this in. AWS has OpenSearch with vector support. Azure has cognitive search. Google Cloud has Vertex AI matching engine. So you don't always need a separate vendor. Now, when do you use it? Anytime your AI needs to retrieve context based on meaning rather than keywords. When do you don't? If your application has low data volume and it requires high precision keyword searching rather than semantic similarity, or if you want to avoid architectural complexity. Feature stores. This one is most of an MLOps concept, but trust me, it matters. Here's the problem. In machine learning, you have features. These are processed, cleaned inputs your model actually trains on. Things like users' average spent in the last 30 days or number of clicks in the last 1 hour. Computing these features is expensive, and here's the kicker. You compute them offline during training, but then you need to compute them again in real time at inference. If these computations are inconsistent even by a slightly fraction, your model performance drops. Now this is called as training serving skew, and it's a silent killer in ML systems. A feature store solves this by storing pre-computed features so you don't recompute them every time. It serves the same features to both your training pipelines and your live inference endpoints. Versioning features so you know exactly which feature were used to train which model. Here the key tools which comes into picture are Feast. This is an open source. We have Tecton, we have Hopsworks, AWS has SageMaker feature store, Google Cloud has Vertex AI feature store. Now, when do you use it? When you have complex, expensive feature engineering, especially in finance services, e-commerce, or fraud detection, when features needs to be consistent and up to date. When you don't use the store, a feature store is unnecessary or impractical for small one-off projects like simple batch processing, all while resources or infrastructure maintenance are limited. Now let's talk about model registries. Once you have trained your model, where does it live? Not just on your laptop, hopefully. A model registry is a version centralized repository for your trained model. Think of it like a GitHub, but for models. Now, what does it store? It stores the model weights and the artifacts, metadata, which dataset was used, which hyperparameters, what metrics it achieved, lineage. Now, what data pipelines produced this model? Deployment status. Is this model in staging, production, or retired state? This is critical for teams. You can promote a model from staging to production. You can also roll back if something goes wrong. You can run A/B tests between model versions. The key tools which comes into picture here are MLflow model registry. This is like a super popular open source. We have weight and biases, the god of all Hugging Face. We have on cloud AWS SageMaker model registry, Azure machine learning, Vertex AI model registry. Now, when do you use it? Always. If you are running ML in production without a registry, you end up with files named as model-final-v3-real-use.pkl, and this kind of a file nobody basically wants. Last one, and this is the unsung hero of AI in production: caching and key value stores. Here's the reality. Running inference on large models is expensive. Every time a user sends a query, you're spinning up compute, running the forward pass, generating tokens. But for a busy AI application, that gets costly fast. Caching solves this in two ways. Now, first one is semantic caching. If two users ask almost the same question, return the cached answer. You don't need to hit the model again for the same answer. Tools like GPT Cache even can do fuzzy matching. So, for example, what's the capital of France and tell me the France capital city can return the same cached response. KV cache for transformers. Now, this is more technical. Transformer models use an attention mechanism that generates key value pairs for every token. Now, during long conversations, recomputing all of this is wasteful. Modern inference engines like VLLM manage a KV cache in GPU memory to speed up multi turn conversational dramatically. Now, tools you'll see are Redis, Memcached, DynamoDB for traditional KV caching. For AI specific semantic caching, you have ChatGPT Cache, LangChain Cache Layer. When do you use it? When you need to reduce latency and cost in production, AI app with high query volume.